The ground beneath the Pacific Northwest isn't quiet. In July 2025, a monster quake near Russia sent shockwaves racing through the planet, and the Cascade volcanoes responded in a way no scientist had ever seen before. They pulsed together, almost as if the entire mountain chain was alive. For hours, Mount Rainier, Mount St. Helens, Hood, Shasta, all beating in the same rhythm, like Earth itself was ringing them like bells. But the mystery doesn't end there, because even without distant quakes, the Cascades have a history of sudden eruptions that rewrite landscapes and test entire cities. The question isn't whether these volcanoes will stir again, it's how, and how soon.
July 29th, 2025. A monster 8.8 quake rips through the Pacific near Russia. Tsunami sirens blare from Alaska to Japan, but hours later, something bizarre begins happening thousands of miles away. America's Cascade volcanoes start pulsing, almost like they're alive.
If the Cascades can sing to a distant megaquake, maybe Cascadia is part of a much bigger engine, the Pacific Plate.
At first, scientists dismissed it as aftershocks. Megaquakes often send shockwaves bouncing through Earth like a bell being struck, but this wasn't random noise. Across the entire Cascade Range, from Mount Baker in Washington down to Mount Shasta in California, seismic monitors began picking up faint, rhythmic pulses, not once, not twice, but in a repeating pattern, stretching for nearly 6 hours. And here's what made experts nervous. These weren't ordinary tremors. They appeared almost simultaneously across multiple volcanoes, synchronized like instruments in a hidden orchestra. The Pacific Northwest Seismic Network had never seen anything like it. Post-quake vibrations are common, but not this structured, not this widespread, and certainly not this regular. Dozens of bursts spaced out in perfect intervals, as if something deep below the Cascades was keeping time. Was this just harmless resonance, or the earliest warning signs that the quiet giants of the Pacific Northwest were stirring together? What came next shifted the entire conversation, because one volcano in particular began acting very differently. And the first to draw attention? Mount Rainier. At 12:17 p.m. on July 30th, barely 8 hours after the Kamchatka quake, a strange swarm of long, low-frequency pulses began echoing beneath its southeastern flank. They weren't loud, they weren't violent, but they were too precise to ignore. Within minutes, the same signals appeared under Mount St. Helens, then Mount Hood, then the Three Sisters in central Oregon. One by one, the Cascade volcanoes seemed to answer Rainier's call. Automatic alert systems quietly triggered across the Northwest. But here's the twist. None of the volcanoes showed eruption signs. No harmonic tremors that usually suggest magma is rising. No GPS shifts to show the ground swelling. No sudden gas release. Yet the signals pulsed on, steady and coordinated. By evening, USGS and top university scientists had convened in an emergency session. The verdict? These were not random aftershocks. They were transient tremor-like pulses, eerily similar to what's seen before eruptions, just without any of the physical changes that normally come with them. So, if the mountains weren't preparing to erupt, what exactly were they responding to? According to Dr. Alina Valdez, it's not an eruption signal. It's more like the mountain is listening, responding to a global pressure wave. And Dr. Andrew Forrester added, these pulses came every 11 minutes, like clockwork. That kind of timing does not happen in geological noise. What made this so remarkable wasn't just Rainier, it was the sheer scale. Data from more than 40 seismic stations lit up at once, showing tremor pulses across nearly 14 different volcanoes. Each signal was faint, but they carried the same rhythm, like the entire mountain chain was keeping time with an invisible metronome. Scientists compared it to a bell choir, each volcano chiming in when struck by a planetary shockwave. But here's the mystery. No one could explain why the Cascades would sing together like this. Dr. Tessa Nakamura described it this way. It's as if the whole arc of the Cascades was gently wrung out, not violently, but just enough to make the mountains hum. And then, almost as quickly as it began, the signals faded. By August 1st, the strange pulse was gone. No eruptions, no ground swelling, no abnormal heat on satellite scans. Official alert levels, still green, but the scientific community, buzzing with questions. The quake that sparked all this wasn't ordinary. An 8.8 release of energy is enough to shift entire plates, not just shake local coastlines. These events ripple outward, redistributing stress across the planet. And the Cascades, resting on their mix of faults, fluids, and magma chambers, acted like tuning forks, hypersensitive to the slightest change. So the question became, were the Cascades simply vibrating like struck strings, or were we witnessing something deeper, a direct interaction between a megaquake and dormant magma systems? Dr. Ian Niles of Stanford put it best. Think of these volcanoes like tightly wound springs. You don't need to snap them for them to respond. Sometimes the gentlest nudge can set them wobbling. And history reminds us, St. Helens erupted in 1980 with only weeks of warning. Rainier, with its glaciers and lahar risks, could be even more dangerous if nudged the wrong way. By early August, researchers began digging into the anomaly with fresh tools. Using matched filter analysis, they compared the Cascades' mysterious pulses against decades of seismic archives. What they found was surprising. The signals looked less like eruption tremor, and more like deep, slow-slip earthquakes, the kind that occur silently along hidden faults. But that raised an even bigger question. Was the Kamchatka megaquake nudging the Cascades' buried faults into motion? Another theory went further. Some scientists whispered about resonance, standing waves rippling through Earth's mantle like sound through a cathedral. Imagine the entire planet ringing like a bell, its vibrations transferring energy to the Cascades' partially molten underworld. If true, this wasn't just seismic noise, it was Earth itself, playing the volcanoes like instruments. At Mount Rainier, sensors recorded tiny but measurable heat changes near fumaroles. At Shasta, geophones detected the first unusual ground noise in years. Japanese and Russian monitoring stations picked up sympathetic tremors in their own volcanic arcs. It was as if volcanoes across hemispheres were quietly acknowledging the same planetary jolt. And that left scientists staring at a startling possibility. Are volcanoes worldwide connected by invisible threads of seismic energy? Dr. Wren of the Global Seismology Institute summed it up bluntly. Volcanoes don't act in isolation. They are part of a planetary system that responds together. For the first time, it seemed the Cascades had proven him right. By that weekend, a cautious consensus began forming. What the Cascades had experienced wasn't magma surging upward. It wasn't eruption tremor. It was something new, what scientists started calling volcanic micro-resonance. Energy from the Kamchatka quake had traveled not just through the crust, but possibly into deeper magma reservoirs, causing subtle oscillations without eruption. In other words, the mountains may have briefly exhaled together. At the University of Washington, Dr. Shawweber noted that GPS stations registered tiny, synchronized shifts across multiple peaks, as if the entire volcanic chain flexed for a heartbeat. In southern Oregon, Newberry Caldera's geothermal output ticked upward, just enough to catch attention. And offshore, hydroacoustic sensors captured faint, low-frequency tones beneath the Cascades themselves, sounds no one expected from a supposedly quiet arc. Despite the strangeness, eruption risk remained low. Gas emissions stabilized, satellite heat scans showed nothing unusual, and the tremor sequence faded. But the scientific implications were enormous. Nearly every major Cascade volcano had responded in unison to a distant quake, pulsing together like linked organs in Earth's body before falling silent again.
Cascadia doesn't need help to be dangerous, but it may be getting it. The same forces rattling these mountains are building pressure all around the Pacific Rim. In September 2025, Cascadia stirred slightly, a 5.8 quake off Oregon, followed by tremors hours later. Minor to most, but for geophysicists, they were reminders that this fault is not asleep, only waiting. If Cascadia ruptures again, experts warn it could unleash one of the largest natural disasters in U.S. history. Cities like Seattle, Portland, and Vancouver could be hit within minutes, followed by a tsunami swallowing entire coastlines. And Cascadia isn't alone in its silence, because to the south, another subduction zone has stayed unnervingly quiet, and history says it's overdue. Along the northern coast of Chile lies what scientists call a seismic gap, a stretch of fault that hasn't broken in far too long. History is clear. In 1868, this region produced a magnitude 8.8 quake. In 1877, another struck at 8.5, devastating coastal cities. Then came a century of quiet. Finally, in 2014, a strong quake hit near Iquique, but instead of relieving the strain, it only snapped part of the fault. Scientists warned it was an appetizer, not the main course. Today, geodetic data shows a massive slip deficit still locked in place, enough to fuel another earthquake as large as the ones from the 1800s, maybe larger. For the millions living along Chile's narrow coast, where desert meets sea, vigilance isn't optional. The silence itself is the warning. And while Chile waits for the Earth to move, another corner of the Pacific has already begun to rumble in rapid, restless bursts. In March 2025, the Aleutian Islands shook with a swarm of quakes, 8 above magnitude 5 in just 2 days. This wasn't the typical main shock aftershock pattern. Instead, the crust buzzed like a hive disturbed, with multiple quakes striking in rapid succession. For seismologists, that's a warning sign. Swarms can mean harmless chatter, or they can signal stress redistributing across the megathrust. And Alaska's megathrust is no stranger to catastrophe. In 1964, the Good Friday quake ripped through at magnitude 9.2, the second largest earthquake ever recorded. It reshaped coastlines, triggered tsunamis, and left scars still visible today. Could today's swarms be whispers before another roar? Nobody knows for sure. But thousands of miles west, another region has already proven just how quickly whispers can escalate into a monster. Off Japan's southern coast lies one of the most feared seismic zones in the world, the Nankai Trough. For centuries, this trench has produced devastating twin earthquakes, ruptures so massive they can span hundreds of kilometers, often striking in pairs only days apart. The last time a full rupture occurred was in the 1800s. Since then, pressure has been quietly building. But in 2023 and 2024, something unusual happened. Instead of a sudden jolt, part of the fault began to creep slowly, what scientists call a slow slip event. Over weeks, instruments recorded the fault sliding almost silently beneath the seafloor. At first, that seemed like good news. Better a gentle shift than a catastrophic rupture. But the reality may be the opposite. These slow slips often mean the shallow edges are sliding, while the deeper sections remain locked, storing enormous strain. Like a bandage peeling at the edges, it could be exposing the point where the real break will come. Then, in August 2024, a magnitude 7.1 quake struck nearby. For Japan's meteorological agency, it was enough to issue a rare public statement. The probability of a Great Nankai rupture had become relatively higher than usual. That's no small warning. Japan is famously cautious in its messaging, often downplaying risk to avoid panic. For them to break that silence is unprecedented. And the stakes couldn't be higher. Tens of millions live within striking distance. Tokyo, Osaka, Nagoya, Yokohama all sit on soft coastal plains that amplify shaking, and history shows Nankai quakes often generate towering tsunamis that reach land within minutes. The question haunting scientists isn't if Nankai will rupture, but when. And if Japan's fault is showing signs of stress, another region to the north may already have crossed the line. In the remote far east of Russia, the Kamchatka Peninsula is one of Earth's most violent seismic zones. And in July 2025, it delivered a chilling reminder of its power. A magnitude 8.8 earthquake tore through the Kamchatka Trench, one of the strongest quakes recorded in over a century. Only a handful of events in modern history have matched it. But this wasn't a sudden surprise. The year before, a magnitude 7.0 rattled the region. 10 days before the monster, a 7.4 struck nearby. Each time, aftershocks multiplied, as if the fault was reshuffling stress in preparation. Then came the main event, a rupture spanning hundreds of kilometers, releasing centuries of locked strain in one colossal pulse. Shockwaves raced across the Pacific. Over 100 aftershocks followed within just 2 days, including 5 stronger than magnitude 6. The rupture zone was so vast it slightly shifted Earth's rotation. Yet here's the paradox. The tsunami was smaller than expected. Deep ocean buoys measured less than 1 meter. By sheer luck, the slip concentrated in places that displaced little water. Coastal towns were spared disaster this time. But the story didn't end there. Just 4 days later, a dormant volcano named Koryaksky awoke after centuries of silence. Ash and gas burst skyward, leading scientists to ask a haunting question. Did the quake itself trigger the eruption? If true, it's proof that Earth's systems are not separate. When tectonic plates shift with this kind of violence, the effects can reverberate into the magma chambers below, unleashing both earthquakes and volcanic fire. Which raises a larger question. Are these disasters really independent or part of a single connected story written by the Pacific Plate? So what ties all of this together? Cascadia's tremors, Chile's silence, Alaska's swarms, Japan's slow slips, and Kamchatka's monster quake. All of it is driven by a single force, the Pacific Plate, Earth's heavyweight, moving northwest a few inches every year. It sounds slow, but over centuries, that motion piles up unimaginable strain where the plate collides with its neighbors. Most years, the stress is released in small quakes that barely make headlines, but when too much energy builds up, the release can be sudden and cataclysmic. That's when megaquakes strike. Here's the unsettling possibility: these events may not be separate. Some scientists argue that one great rupture can nudge others thousands of miles away, transferring stress, altering Earth's rotation, even redistributing mass across the planet. Could Cascadia, Chile, Japan, and Kamchatka all be part of the same larger cycle? The science is still unsettled, but the pattern unfolding today has many wondering if Earth's largest tectonic engine is rumbling in sync. And earthquakes may not be the only danger, because when the ground shifts, the volcanoes above often follow. When tectonic plates shift, the effects don't stop at earthquakes. They can awaken the fiery world beneath our feet. In Kamchatka, the 8.8 quake was followed just days later by a volcanic eruption, a rare but chilling reminder that seismic stress can stir magma systems. In Chile, a chain of snow-capped volcanoes towers above the Andes, each fueled by the same subduction forces that drive the quakes below. And in North America, the Cascadia Fault is linked to the Cascade Volcanoes, giants like Mount Rainier and Mount St. Helens, looming over millions of people. When the ground rips apart, it doesn't just unleash shaking, it can unclamp magma, destabilize reservoirs, and trigger eruptions. The result, disasters that combine the worst of both worlds. But not all threats live on the rim. Some hide in the deep, scars so vast we mistook them for ocean floor.
Enter Appalaki. Deep beneath the Philippine Sea lies a scar 150 kilometers wide. That's nearly twice the size of Yellowstone's caldera, wider than the entire country of Iceland. For decades, scientists overlooked it. It blended into the seafloor, a vast circular depression that looked ordinary. But in 2019, high-resolution sonar mapping exposed the truth. A perfect circle, a collapsed dome, a volcanic scar unlike anything ever seen before. This wasn't a random basin, it was the skeleton of a supervolcano, the largest caldera Earth has ever revealed. The world named it Appalaki, after a Filipino sun god. But to geologists, it might as well mean the giant lord. And here's the chilling part. If Yellowstone is America's ticking time bomb, Appalaki is Earth's sleeping giant. So how was this monster born? Rock cores drilled from the plateau tell a story written in lava. 47 million years ago, magma surged upward. Not for days, not for years, but for nearly 20 million years straight. Lava poured across the ocean floor, piling layer upon layer. The plateau grew thicker than Mount Everest is tall, an entire mountain range beneath the waves, and then collapse. The chamber beneath emptied in a catastrophic eruption. The weight of the ocean above pushed downward. The seafloor cracked and caved. What remained was Appalaki. Its floor lies nearly 5 kilometers deep. Its rim rises in scalloped ridges. Its center holds a resurgent dome, proof of later volcanic pulses. It is, by every measure, colossal. But the question that haunts scientists is simple. Is it extinct or only asleep? To answer that, we look at Earth's other titans. Yellowstone, still alive, its ground breathes in slow motion, swelling and sinking with magma pulses. It last erupted 640,000 years ago, and it will erupt again. Toba, Indonesia. 74,000 years ago, it released 2,800 cubic kilometers of ash. Global temperatures plummeted. Some scientists believe humanity's population nearly collapsed. Krakatoa, 1883. An explosion heard 3,000 miles away. The sky turned dark. Tsunamis killed tens of thousands. And the Gakkel Ridge beneath the Arctic. 1 million years ago, it unleashed a submarine eruption so vast it reshaped the ocean floor. Each of these events reshaped history, but Appalaki dwarfs them in scale. So if those giants still breathe, why not Appalaki? For a long-dead caldera to awaken, 4 ingredients are needed. First, pockets of molten rock must remain. If Appalachi's chamber is fully frozen, the story ends there. Second, fresh heat must arrive, a mantle plume rising from the deep, or an unusually hot slab edge feeding magma upward. Third, tectonic stress must crack open new pathways. And in 2025, we've seen just how powerful those stresses can be. And finally, water. Appalaki sits entirely underwater. If magma meets seawater, the result is cataclysmic. Krakatoa proved that in 1883, and it was tiny compared to Appalaki. Imagine magma surging upward, boiling seawater into superheated steam, explosions powerful enough to shatter the ocean itself. If Appalaki stirred, the ocean wouldn't protect us. It could amplify the disaster. So, is there any sign this could happen? At Yellowstone, instruments detect constant rumblings. At Appalaki, silence. No swarms of quakes, no uplift, no heat anomalies. Most experts believe Appalaki is extinct, its chamber frozen solid. Its fiery age ended tens of millions of years ago. But here's the danger. Appalaki lies in international waters. No seismic arrays sit above it. No satellites track its subtle shifts. Almost no monitoring at all. If changes were happening beneath the Philippine Sea, would humanity even notice before it was too late? Let's imagine the unthinkable. If Appalaki erupted again, the scale would depend on the magma. If it were basaltic, we'd see enormous lava floods, slow, relentless, altering the seafloor, disrupting ocean currents, killing marine ecosystems for centuries. But if the magma evolved into silica-rich forms, explosions, ash clouds, tsunamis radiating across the Pacific, sulfur dioxide would darken skies. Global cooling could last years, crops would fail, economies could collapse. Even if only a fraction of Appalachi's original volume erupted, it could rival the largest disasters in Earth's history. So could humanity survive? Maybe, but civilization as we know it would never be the same. So, should we worry? Probably not. Appalaki shows no signs of life. Its magma chamber is likely sealed and frozen, but its existence is a reminder. Earth has created giants before. It will create them again. The Pacific Plate keeps moving west. The ring of fire keeps breaking and burning. Volcanoes like Yellowstone still breathe. Appalaki may sleep forever. But the forces that built it, the same forces shaping our planet right now, are far from finished.
And while that global connection remains a mystery, one fact is undeniable. The Cascades don't need a distant megaquake to be dangerous. On their own, these mountains have a history of eruptions powerful enough to rewrite landscapes and threaten millions.
The Pacific Northwest isn't just home to forests, coffee, and tech giants. It sits on top of a chain of volcanoes capable of rewriting history in a single day. From Northern California to Canada, the Cascades are a lineup of some of the most dangerous peaks on the continent, many of them towering over millions of people who rarely think about what's beneath their feet. Just this summer, Mount Rainier reminded scientists how alive these mountains really are. More than 1,300 small earthquakes shook its slopes in only a few weeks, the most ever recorded there. None were strong enough to knock dishes off shelves, but together, they signaled that deep underground, something was moving. And if history has taught us anything, it's that ignoring those signals can be costly. Mount St. Helens proved that in 1980, when it tore itself apart in one of the most violent eruptions in U.S. history. That was one volcano, on one day, but there are more than a dozen giants here, each one with the potential to change the Pacific Northwest forever. Now, with new swarms of quakes, shifting ground, and strange gas releases making headlines, the real question isn't whether these volcanoes will erupt again, but whether we're watching the first hints of what's to come. Not all volcanoes are built the same, and the Cascades are the worst kind to underestimate. Unlike the broad, slow-moving shield volcanoes of Hawaii, most Cascades are stratovolcanoes, steep, layered peaks made of hardened lava, ash, and shattered rock. That mix makes them unstable, and when they erupt, it's rarely gentle. Stratovolcanoes specialize in explosions, towering ash plumes, fast-moving pyroclastic flows, and floods of mud and debris called lahars. The reason they exist at all lies far offshore. The Juan de Fuca Plate, a chunk of Earth's crust sitting under the Pacific Ocean, is slowly sliding beneath North America. This process, called subduction, drives water and minerals deep into the mantle, melting rock into magma. That magma has only one way to escape: up. And where it reaches the surface, it builds volcanoes like Mount Rainier, Mount Hood, Mount Shasta, and dozens of smaller cones that dot the landscape. Stretching for more than 700 miles, the Cascade Arc is a volcanic assembly line, and while not every peak erupts often, history shows that any of them can. That unpredictability is what makes the Cascades so dangerous, and why scientists treat every tremor, every gas leak, and every bulge in the ground as a potential warning sign. The Cascades have a rhythm, long silences broken by moments of chaos, and when those moments come, they can rewrite landscapes overnight. The most famous example is Mount St. Helens in May 1980. After weeks of tremors and swelling, the mountain's north face gave way in the largest landslide ever recorded. That collapse uncorked a sideways blast so powerful it flattened forests across 230 square miles and sent ash circling the globe. 57 lives were lost, billions of dollars were spent in recovery, and the Pacific Northwest learned just how destructive one volcano could be. But St. Helens is far from alone. Mount Rainier, the tallest peak in the Cascades, has erupted many times in the past 10,000 years, and its icy slopes mean even a small eruption could unleash massive lahars barreling into nearby valleys. Mount Hood erupted in the late 1700s, its ash and lava flows reminding Portland that the mountain is anything but dormant. Farther south, Mount Shasta has erupted repeatedly over the past 4,000 years, while Mount Mazama's colossal eruption 7,700 years ago created Crater Lake, one of the most dramatic volcanic scars on the continent. Even recent history holds reminders. Mount St. Helens stirred again in 2004, this time growing a new lava dome over the course of 3 years. It was quieter, almost surgical compared to 1980, but proof that the volcano is still very much alive. The pattern is clear. Cascades volcanoes don't erupt often, but when they do, the results are catastrophic. And the silence in between, it's not reassurance, it's buildup. For years, the Cascades have been mostly quiet, but recently, that silence cracked. In July 2025, Mount Rainier experienced its largest earthquake swarm ever recorded. More than 1,300 tiny quakes rattled the volcano in just a few weeks, at times spiking to 40 tremors an hour. Most were too small to feel, but to scientists, the message was loud and clear. Something was shifting deep inside the mountain. Was it magma pushing upward? The USGS says no. The data points instead to fluids moving through cracks in the rock. Still, it's a reminder that Rainier is active, complex, and unpredictable. And it wasn't just Rainier. Mount St. Helens, Mount Hood, and even Mount Adams have all registered small quakes and gas releases over the past year, the kind of background activity that scientists expect from living volcanoes. By early September 2025, USGS reported that all Cascade volcanoes remain at normal background levels. In other words, calm for now. But history shows that calm doesn't always last. Eruption cycles can shift suddenly, and swarms like Rainier's are exactly the kind of whispers that scientists watch for, because sometimes whispers turn into warnings. If history proves anything, it's that the Cascade volcanoes will erupt again. The real question is, which one and how bad will it be? Scientists consistently rank Mount Rainier as the most dangerous volcano in the United States. It's not just its height, it's the ice. Rainier is covered in massive glaciers, and even a small eruption could melt enough ice to trigger lahars, walls of mud and debris racing down valleys at highway speeds. For communities in Washington, that could mean as little as 30 to 40 minutes to evacuate before entire towns are buried. Then there's Mount Hood, just 50 miles from Portland. Its eruptions are typically smaller than Rainier's, but its location makes it a serious threat. Ashfall could choke highways, contaminate water supplies, and disrupt a metro area of over 2 million people. Farther south, Mount Shasta is one of the largest volcanoes in the range. It has erupted often in the past 4,000 years, and its position near key transport corridors means even a moderate event could cut off major highways and devastate local communities. And of course, Mount St. Helens, the repeat offender. Its crater still steams from time to time, and scientists consider it one of the most likely Cascade volcanoes to erupt again within our lifetimes. Another explosive blast like 1980 is unlikely thanks to the crater's collapse, but smaller dome-building eruptions, mud flows, and ashfall remain very real threats. Even the lesser-known peaks, Glacier Peak, Mount Baker, the Three Sisters, have erupted in the past and show signs of unrest. In other words, the danger isn't concentrated in one mountain. The entire arc is alive, and the next eruption could come from where it's least expected. The threats go beyond lava and ash. Power outages, flight disruptions, contaminated crops, and billions in economic losses are all part of the picture. A cascade eruption wouldn't just be a local disaster. It could ripple across the entire country. The good news is that we've never been better at tracking volcanoes. Across the Cascades, a web of seismic sensors, GPS stations, gas detectors, and satellites keeps watch 24/7. At the Cascades Volcano Observatory in Washington, scientists study every tremor, every ground shift, every wisp of gas. That network means we'd almost certainly get early warning signs before the next eruption. Days, weeks, or even months of notice, depending on the volcano. Communities near Rainier, St. Helens, and Hood already have hazard maps, evacuation routes, and regular drills. But there are limits. Monitoring coverage isn't perfect, and funding only goes so far. Some valleys still don't have dense sensor networks, and nature doesn't always play by the rules. A swarm of tiny quakes might lead to nothing, or it might be the first clue of something larger. Forecasting is still more art than science. So is a major eruption imminent? Probably not. Right now, every Cascade volcano is officially at normal background levels. But the key word is right now. The quiet we're living through is temporary, and one day it will end. The Cascade volcanoes aren't relics of the past. They're active, living systems. Mount Rainier's record-breaking swarm this summer is proof that these giants still stir beneath the surface, even if the ground above looks calm. History guarantees that another eruption will come. Maybe it's decades away, maybe longer. But as cities sprawl closer to hazard zones and glaciers retreat from warming climates, the risks grow more complicated. An eruption in the Cascades wouldn't just test scientists, it would test how prepared we really are. For now, the mountains rest. But rest isn't the same as peace. The silence will break. And when it does, how we respond will decide whether it's remembered as a tragedy or a survival story. So what do you think? Are the Cascades quietly gearing up, or just reminding us who's really in charge? Drop your thoughts in the comments, and let's talk about it. Thanks for watching Geosphere. Subscribe if you want more deep dives into the forces shaping our planet.